Alright, so let's continue Gym Academy. I'm sorry I got like sort of lazy for past few days, so I didn't do any video. Alright, so today we're gonna introduce force. Force. So what exactly is force? We all know force. You apply force to something and something will move. Alright, so we say um here's a ball. It's at rest. So how do we make it move? Well, you exert a certain amount of force, so the ball will move. Right, so let's think about the ball, like when the ball is moving. So when the ball is moving, what actually happens? When the ball is moving from rest, actually a force exerts on it, and then it accelerates the ball to like a non-zero velocity, so the ball will keep on moving. So the force equals to mass times acceleration. So therefore, two things matters in force, which is mass and acceleration. Let's think about it. So for let's say mass. About mass, why does mass matter? Think about if there is a building that's like 100 meters tall, high, and then here's like a little small box that's like zero point 0.2 kg fell down, and then you're like right beneath the box. So the box will hit you in the head, and you'll be like, "Who the you know what I'm saying?" Alright, so you'll be pissed, you know. And then what if there's like this giant box that's like 1,000 kg, which is 1 ton, and it hits you straight up in the head? See, you're not even gonna have a chance to complain because you're gonna be like killed, like for sure. So see clearly the same acceleration, which is 9.8 meters per second square, which is gravity. These two boxes with different masses exert different forces on your body. That's why for this box, all you have to all that's gonna happen is that you're gonna get hurt and you're gonna complain. In this box, you don't have a chance to complain. All right, so for acceleration, it's also really easy to understand because like if we say that you and me are both trying to push a ball that's 1 kg, 1 kg, and then I am exerting a force that's making the ball accelerate, let's say 1 meters per second square, and you're like a superpower guy, and you're trying to like accelerate this ball by like maybe like 100 meters per second squared, and of course you're exerting a larger force than I am. So yeah, like the bigger the acceleration is, the bigger the force is. Actually makes a lot of sense. All right, so some people may have a question that like, all right, so if we say force is ma, then if acceleration is zero, like there's no force to it, right? Yeah, like the net force is zero when acceleration is zero. So some people may ask like, all right, so if a ball is moving in a velocity of like maybe 1 meter per second, constant velocity, no acceleration, and then so how come this thing can like keep on moving like that if there's no force? Well, if there is no counter force to this object to slow it down, the thing theoretically, the ball will like move forever. So why in reality the ball does not move forever? Because there's a force of friction that's going against the ball. That's why the ball is not moving forever. But neglect friction. If there is no friction in this world, the ball will keep on moving non-stop until there's a counter force acting on it. So in physics, we have this term called net force. What is net force? And so again, there's a ball. I exert a force here. I exert the same amount of force here. What is the net force? Is the total force on this ball? Well, clearly this and this cancel out, so this is zero. The net force net equals to zero in this case. Let's do another example, let's say if this is a ball right here, and then here is a force exerting on it. Let's say this force is 10 newtons, and then another force is acting like this, and then the angle between these are, let's say, 30 degrees, and then here is another 10 N. So what is the net force? Actually, you can divide this 10 into two parts, horizontal and vertical. So what is a horizontal? The horizontal is going to be 10, 10 times, it's going to be cosine 30 times 10, which is going to be, let's see, 30 and then cosine, yeah, this number, times 10, and that equals to, wait, what is this? This is not even right. Oh, what did I even do? All right, so 30 cosine times 10, that's the number 8.66. That's a horizontal force. So 8.66 newtons. That's a horizontal. And vertical is going down like this, like this. All right, so vertical is sine 30, which is 0.5 of course, times 10. So this is actually 5. And then you add all these up, so it's 10 subtracted by 8.66. So that's gonna be, so the horizontal force of this is gonna be 1.34, and downward force is gonna be 5. So if you do Pythagorean theorem, and then let's say if this is a right triangle, so this is gonna be, the hypotenuse is gonna be net force. So net force is gonna be 1.34 squared plus 25, which is 5 squared, plus 25, and then square root of this entire thing. I really don't want to calculate it, so I'll just leave this to you. All right, so this is pretty much like this is my introduction of force, and in the next video I'll show you guys how to do that whatever elevator problem that you guys often get always get. All right, so see you.